In this question, we're told that a car passes point A with a speed of 5 meters per second. The car accelerates at a constant rate, and 8 seconds later, it passes point B with a speed of 20 meters per second. We're asked first to find the acceleration of the car. Okay, just a quick diagram just to keep everything in check. Yes, we have point A and point B, velocity of 5 and a velocity of 20, and it took 8 seconds to happen. Let's collect some SUVAT variables. Initial velocity 5, final velocity 20, time of 8. Let's find the acceleration. The formula here is V equals U plus AT. And as we substitute our values in, we just need to rearrange to make A the subject, and we get an acceleration of 15 over 8 meters per second squared. Part B wants us to find the distance from A to B. So we can use the same variables, but this time we're looking for displacement. So the formula, let's go for S equals half U plus V times T. Okay, substituting in, 5 plus 20, multiplied by 8 and divided by 2, that gets us 100. The displacement, 100 meters. The distance from A to B, 100 meters. Part C asks us to find the time it takes the car to reach the midpoint of AB. Now, a lot of students jump in and they try to half the time and think, well, how far has it gone in 4 seconds? Or they think the answer is 4 seconds. But this isn't true. We know that the car is moving with a higher velocity at the end of this observed journey, meaning it's covering more ground per second. So it travels a lot further in the last 4 seconds than it does in the first 4 seconds. We've got to make sure we're considering the midpoint in terms of the distance. So if this was 100 meters from A to B, well, the midpoint is when we've traveled 50 meters. How long did it take us to travel 50 meters? Okay, let's set that up. We're collecting some new SUVAT variables. This time, the displacement is going to be 50. The initial velocity is 5. We don't know the final velocity. It's not the 20 that we had before. Be very careful here. The acceleration, 15 over 8. Yes, we found that. And the time, once again, we do not know. It is not the 8 seconds from before. Okay, we're looking for time. The formula to use, S equals UT plus half AT squared. Let's go ahead and substitute all of that in. As usual, we're generating a quadratic equation. So rearranging and solving should help us to find T. This should go into your equation solver and you'll get two solutions, 5.1 and negative 10.4. We know that we're not interested in a negative time. That wouldn't make sense in our context. That would be 10 seconds before we started watching the car. So we eliminate that, and the answer we're looking for is 5.1 seconds. It takes 5.1 seconds to reach the midpoint of AB.